Myself, Sunil Raute, Kohinoor Arts, Commerce and Science College, Khultabad. Myself, Mr. Sunil Raute, Assistant Professor, Department of Chemistry. This video is made up for the BSc third year, 5th semester, paper number XIV, Organic Chemistry, chapter 1st, Spectroscopy, part 2. Today we will see here the multiplicity of the H1 NMR signal, spin-spin coupling. There are the NMR spectrum is its peak is appears like different signals. That is very important to know the behavior of the neighboring protons from the neighboring proton of the carbon, and because of that only this H1 NMR spectrum arises, or it's come into this analysis spectrum windows. This is a Pascal triangle. If the one hydrogen is there, the peak intensity, as this is singlet only, this is singlet, the peak intensity, this is singlet, this is also singlet, the peak intensity is only one peak is there, and that equal peak, then this is split into two, means if doublet, two proton is there, means 2Ni plus 1, 2Ni, 2, N is equal to 1, Ni plus 1, sorry, Ni plus 1, two signals. Neighboring proton is, if the neighboring proton is 0, at that time its signals come is singlet. If neighboring proton is 2, this 2 means Ni plus 1, means Ni is equal to 1, 1 is neighboring proton, and plus 1 plus 1 is equal to 2, then signal is arises 2. This is the two signals arising, and that two signals are, the intensity of these two signals are same. This is a Pascal triangle. Similarly, this goes down. If the proton is 3, neighboring proton is 3 2, sorry, then the signal is arising triplet, means Ni plus 1, means 2 plus 1 is 3, this 3, this is but 1 as 2 as 1, this is a signal 1 as 2 as 1, this is a triplet signal. Then for proton number is 3, then it's into Ni plus 1 is equal to 4, these 4 signals are appear, and that is a quartet. Then once again that splitted, this comes here, and this peak is big one, because of it's merge of two peaks here, and after that the proton number is 4, then quintet, N plus 1, 5 plus 1, 4 plus 1 is 5, and then signal is arising quintet, 5 signals are arising. Similarly, again one proton added, then 5 proton is there, that time neighboring proton is 5, then sextet, then septet, and it's also this quintet, sextet and septet is also it's generally called as the multiplet. And these types of signals are arising in H1 NMR spectrum, and from integration, means summation of these peaks, from there we are calculate the hydrogens of in that molecules or in that spectrum. Then coupling constant, there are different type of coupling constant. Neighboring proton or vicinal proton, they are showing some indications, coupling constant. What is the coupling constant? Coupling constant is that this difference is known as coupling constant. This difference is known as coupling constant, from this to this peak, known as the coupling constant. This from number of series Cn, and this C and this C, these two proton couple each other, but this is not couple actually. In this case, at that time the coupling constant value of J is a coupling constant, and this value is 0. Then this CH3 CH2, this is a neighboring proton, vicinal proton, it is neighboring proton, vicinal proton, and these signals highlighted here showing 6 to 8 coupling constant. Then this CH is there. There are two. They are showing also 5 to 7 coupling constant. Then X and Y, this hydrogen showing coupling constant 2 to 12. Depends upon the dihedral angle and the nature of the X and Y. Depend on this. Then this aldehydic proton is showing also 0.5 to 3. Then vicinal proton 12 to 15 must be diastereoscopic. If the diastereoscopic center is there at that time, this vicinal protons showing the signals near about 12 to 15. Then in unsaturated compounds, unsaturated means here trans coupling is there in double bond is near about 12 to 18. Cis coupling is there is near about 7 to 12, and geminal coupling of that CH2 is in unsymmetric carbon or double bond carbon means compounds, it is 0.5 to 3. Then allylic hydrogen of this compound, its coupling constant is 3 to 11, depends on the dihedral angles. Then alkyne, from alkyne the proton coupling is near about the, this is not a vicinal actually, or not adjacent, it is far away. It also showing the coupling constant near about 2 to 3 joule hertz. Then it is benzene ring. There are ortho, meta, para. The ortho position of hydrogen ortho position is there, and that coupling constant is ortho position 6 to 9. Then meta, from here and here, the meta coupling is near about 1 to 3, and para coupling is near about the 0 to 1. Then this is alkane is 6 to 8 hertz. Then cis coupling is 6 to 15. We have seen this, but I want to show here ortho coupling 7 to 10, near about 6 to 10 near about. And then meta coupling, this is a meta coupling is 2 to 3 hertz, and para coupling is 0 to 1 hertz. Then we are calculated here the unsaturation, degree of unsaturation numbers, and that is a formula to calculate the unsaturation number. The 2C plus 2, the 2C means 2 into carbon plus 2 plus nitrogen minus hydrogen minus halide. X is the halide, and this is 2. Carbon, hydrogen, nitrogen, and halogen. X is the halogen. Then for nitrogen, C for carbon, H for hydrogen. The from this we are calculation the for example, we calculate the unsaturated DUE number of CH4 compounds, means how many double bond degree of unsaturation numbers in these CH4 compounds. Then we kept the values of carbon here, this is 1, then hydrogen here 4, there is no nitrogen, there is no halides. Then we calculate this how to solve these equations. This is a ordering of mathematical operation. There is Born-Mass operation, we say like that. In there is the first solve the brackets, then orders of then division, multiplication, and addition and subtraction. From here we solve this first multiplication here, 2 into 1 is equal to 2 plus 2 plus 0 minus 4 is equal to this 2 plus 2 is 4, 4 minus 4 is equal to 0, and then 0 divided by 2 is equal to 0. It means from du number is equal to 0, it means no unsaturation in the molecule. Means in this molecule there is unsaturation number is not there. Then you see the next example, the molecular formula C2H5Cl. Take another formula. What is that? Carbon number is here 2, then chlorine, halogen is there, halogen number is 1, and hydrogen is 5. Then we calculated here 2 into 4, 4 4 plus 2 plus 0 minus 5 minus 1. This minus minus get plus and it convert into 6. Then 4 plus 2 is equal to 6. 6 minus 6 is equal to 0, and then 0 divided by 2 is equal to 0. Here also in this formula there is double bond is not exist here in this formula. This is help to know number of unsaturation, how much unsaturation is there. From this formula we calculated the number of unsaturation from this molecule. Then molecular formula C3H7NO2. In this formula the carbon number is 3, then nitrogen, there is one nitrogen, halogen not, hydrogen is there, max halogen is not there. 1 minus 7 minus and 6, 3 into 2 is 6, 6 plus 2 6, and this 7 1 minus 7 plus 1 is equal to 6, and 6 plus 2 is equal to 8, 8 minus 2 is equal to 2, then 2 by 2 is equal to 1. The number of unsaturation here is single unsaturation, means there is a one double bond is there in that molecule. From this formula there are we predict different molecules, but it is from which exactly molecule is there. For that purpose we have to that NMR signals. If the NMR signal is there, we actually correctly calculated the which molecule is this. From there is a number of signals, means here in this molecule 1 2 3 4 signals are arises in H1 NMR spectrum. In this compound there is only this one proton and these are the same, means only 2 signals arises in this molecule. Here 1 2 3 4 signals arises in this molecule. In this molecule 1 2 3 signals arises in this molecule. 1 2 3 signals arises in this molecule, like this. Means number of set of proton is there, here 3, here 4, here 2 set of protons here there. From the H1 NMR spectrum we predict that the which molecule is this. Then next example is the molecule formula C4H8. Then here is only carbon and hydrogen. We calculate carbon, put carbon value here 4 and hydrogen value here 8. The 8 plus 2 is equal to 10 and minus 8. 10 minus 8 is equal to 2. But 10 minus 8 is 2. 2 by 2 is equal to 1. Here is also one unsaturation, but there are different functional structural isomer is there. There are these 2 3 4 5 6 7 or number of structural isomers are possible from this formula, but which is the exactly compound that for that purpose we have NMR signals there, NMR signals or NMR data is there. If, from that data we calculate the exactly which compound is this. Then the molecular formula is C6H6. Carbon is 6 and nitrogen is 6. There is no oxygen and halogen is there. Means 6 into 12, 12 plus 2 is equal to 6. 12 plus 2 minus 6. 14 minus 6 is equal to 8 by 2. Means 4 number of unsaturation. Where is 4 number of these? 3 double bond is 3 unsaturation and 1 ring residue is the fourth. And this is the not only single structure, but we have to showing, for example only, this is the benzene structure of the, and it having a number of unsaturation is 4. Then the example 5, molecular formula C6H4NO2Br. In this there is a halogen also or nitrogen also. We put these values here to 6, 12 plus 2 and the 1 nitrogen, 4 hydrogen and 1 halogen. Means 12 plus 2 minus 4, 12, 14 minus 4 is equal to 10 by 2 is equal to 5. 5 a number of unsaturation, means this 3 ring double bond and this is a 4th ring residue and it is the 5th. Here also there is only O minus is there, O is minus here and double bond here. This is also possible structures. Then possible structure. Then next video we see that the exactly from NMR spectrum how we know the exact structure of the molecule. For today it is enough. Thank you.